It's an exciting day here at the Treehouse, mathematicians. Final inspection time. I'm going over everything with a fine-toothed comb to make sure the treehouse is safe, well-made, and ready to gift to Mia. Everything has been checked off my list except one triangular brace. It isn't aligned properly, so it's not doing its job to support the roof structure of the treehouse. Once I fix this issue, I can put a big bow on the door and invite Mia over to see her thank you present. So, can you help me figure out what's going on with this brace? All right, here's a sketch of the brace causing the problem. See the gap between the ceiling and the top of the triangular brace? That means the ceiling isn't actually resting on the brace, which is kind of the whole point of having one. This brace here, though, is exactly right. The triangle fits right into the corner and the brace is supporting the ceiling. What are the similarities and differences between the two braces? Compare and contrast them in your notes now. Great work! The main similarity is that they're both triangles, but the primary difference is that they have different angles. The different angles are what make the triangles shaped differently. Earlier, we learned about three types of angles: acute, right, and obtuse angles. Take a moment now and draw examples of these angles in your notes. In that same chart, write the definition for each angle type 2. Compare what you wrote down to how I filled in the chart. Pause the video if you need to make any changes. Just like there are different types of angles, there are also different types of triangles, like we saw in the treehouse braces. We can classify or label triangles based on the types of angles they have. Fill in your chart as we talk through the differences in the three types of triangles. In acute triangles, all three angles are acute. A right triangle has one right angle, and then in an obtuse triangle, one of the angles is obtuse. Compare your chart to mine and pause if you need to. All right, let's practice classifying some triangles ourselves. When classifying triangles by their angles, it's helpful to know all three angles before deciding whether it's acute, right, or obtuse. Take a look at this figure here. Thankfully, all three angles are already labeled with their measures. Now, we need to determine what type of angle each one is. Angle A is 50 degrees. That's an acute angle. Angle C is 32 degrees. That's also an acute angle. But angle B is 98 degrees. That's an obtuse angle. What type of triangle do you think this is? Since there's one obtuse angle, this entire triangle is classified as an obtuse triangle. This next triangle, triangle DEF, is different. Angle D is 81 degrees, and E is just 9 degrees. So they're both acute angles. But angle F is 90 degrees, which means it's a right angle. What's the name of this type of triangle? Since there's one right angle, that means the entire triangle is classified as a right triangle. What about this last triangle, triangle GHI? Angle G measures 62 degrees, angle H measures 58 degrees, and angle I measures 60 degrees. Those were all acute angles. When all three angles in a triangle are acute, that means it's an acute triangle. Now it's your turn. Classify these three triangles by type. Feel free to refer back to the completed table in your notes for help classifying triangles. Triangle MIA has one right angle, so it's a right triangle. Triangle URL is all acute angles, so it's an acute triangle. And lastly, triangle BED is an obtuse triangle because it's got one obtuse angle. Great work with these triangles. But do you think you could handle classifying a triangle where you don't know all the angle measures? We need to be able to do that in order to figure out the correct brace for our treehouse. Let's try classifying triangles with unknown angles to make sure we're ready to tackle the treehouse brace. Here's a word problem. In triangle TRY, angle T measures 36 degrees and angle R measures 42 degrees. Classify triangle TRY. Where should we start? Well, to classify a triangle, we have to know the three angles that make up that triangle. So let's sketch our triangle out so that we have a visual. Follow along in your notes. How can we figure out the missing angle? Yep, one method is to write an equation. Let's follow the part plus part plus part equals whole setup. Remember, the angles in a triangle add to 180, meaning the whole for triangles is always 180 degrees. The parts we know are 36 and 42, and we can use y as the unknown angle, so we have 36 plus 42 plus y equals 180. Pause the video here to find the missing angle. Then identify what type of triangle this is. It's solving time. I need to add 36 and 42 because they're my like terms, and that leaves me with 78 plus y equals 180. I subtract 78 from both sides, and my final answer is y equals 102 degrees. I quickly check my work with addition. 36 plus 42 plus 102 is 180. And now that we know the three angles, look at each angle and decide. Is it acute, right, or obtuse? Angle T is acute, angle R is also acute, but angle Y is obtuse. What type of triangle has one obtuse angle and two acute angles? Yes, an obtuse triangle. So we finish our work by writing our final answer. Triangle TRY is an obtuse triangle. To classify a triangle with an unknown angle, we work through a series of steps. Step 1, set up an equation to find the missing angle. Step 2, solve the equation. Step 3, evaluate all three angles to classify the triangle. You'll notice we waited until we knew the measure of all three angles before deciding what type of triangle it is. Okay, here are the two braces used to support the treehouse roof. Perhaps the brace I need to fix is the wrong type of triangle. Pause the video to determine the missing angle in each triangle, then classify each triangle as acute, right, or obtuse. We'll start by focusing on the brace that doesn't fit. Step 1 says, set up the equation. So I set up 65 plus 55 plus x equals 180. Now for step 2, solving. I combined my like terms to get 120 plus x equals 180. Then I isolated my variable by subtracting 120 from each side. I found that x equals 60. So the angles in this triangular brace are 65 degrees, 55 degrees, and 60 degrees. Now that we know all three angles, step 3, let's classify this triangle. So none of these angles are larger than 90, and none are exactly 90. They're all acute. So now we know that the brace that doesn't fit is an acute triangle. Let's compare it to the brace that does fit. My equation, and remember yours could have been in a different order, was 45 plus 45 plus x equals 180. I combined my like terms to find 90 plus x equals 180. Then I isolated the variable by subtracting 90 from each side. I found out the missing angle is 90 degrees. This means the brace that fits is a right triangle because it has one right angle. So that's why the other brace doesn't fit. It's an acute triangle, but it needs to be a right triangle in order to support the ceiling. All I need to do is replace the acute brace with one that's shaped like a right triangle, and I'll be ready to give Mia her thank you present. I'm so excited to share this treehouse with her. Thanks so much for your help building this angle-filled treehouse. Until next time, keep questioning, keep calculating, and remember, the type of triangle depends on the angles inside. See you next time.
Hey!